Everyone leaving the meet? It's okay. Yeah, shall we wait for 5 more minutes? Or shall we start the class?
Yes, we can wait.
Okay. Yeah, then we will start today's session. So basically today we'll be seeing a few problems from week 6. So we will be solving problems related to amplifiers, then RC based circuits and power related questions. If since today is a 2 hour session, if there is enough time, we will also see summary of week 7. Is it fine?
Yes, ma'am. After like when you will solve RC problems, so please explain a bit of topic because at the end I was not able to understand it completely.
Okay. Yeah, sure. So yeah. So the first question is we have to find the power absorbed by the 5 kilo ohm resistor in the given circuit. So the circuit is, that is a 1 ampere current source connected in parallel to a 5 kilo ohm resistor, which in turn is connected to a 5 ampere current source. So we are going to find the power absorbed by the 5 kilo ohm resistor. Yeah, try solving it and tell me the answer.
Okay, I'm just solving. Ma'am, it will be 20 kilovolt, 20 kilowatt.
What is the formula for power?
Sorry.
V is
It's
equals to
even.
IV.
Yes. So yeah, solve it again. What is the answer?
Minus 80 watt.
Why is it minus 80?
No, it will be plus 80.
Yes, the answer is plus 80 watts. So we have to find the power absorbed by the 5 k ohm resistor. To find the power absorbed by the 5 ohm, it's nothing but
So
the
it will
current through the
be
5 ohm
plus
resistor.
80 kilowatt.
Yes. So this is the formula for the power. Since resistors generally absorb power, and in the question they have asked absorb, the sign is plus, right? Do anyone have any doubt with the sign? Why
Oh, okay.
it's
Got
less
it,
of-
ma'am.
Yeah. So what is the current through the 5 ohm? How will we find it?
Yeah, KCL.
Yeah, applying KCL at the point node 1. By KCL, the current entering will be equal to the current leaving. So what are the current that are entering?
1 ampere is entering and 5 is 5 and what like the I is leaving.
I'll just assume this in this direction x. So x is equal to 4
4.
amperes, right? So the
Yes.
current through the 5 ohm is of 4 ampere. So it's 4 square into 5k.
R.
It's
5.
basically
Yes.
16 into 80k. What is the unit of power?
What,
Watt.
ma'am?
Unit of power. It's watts.
Watts. Yes.
Shall we move to the next question?
Yes, ma'am.
Yes, ma'am.
So the next question is find the power delivered by the 1 kilo ohm resistor. So my circuit is, there is a 1 ampere current source connected in series with another 1 ampere current source, and this combination is again connected to a 1 kilo ohm resistor. What is the power across the 1 kilo ohm resistor now?
1 ampere.
Find the
1
power
watt.
delivered by the,
Minus root.
see it is delivered, no? What is the, please tell me the sign and the value.
Yeah. -1.
Yes. So
Minus 1 kilowatt.
yes, the resistor absorbs power, but in the question they asked deliver, so it is minus the current flowing through the 1 k ohm resistor square into R. What is the current flowing through the 1 kilo ohm resistor? What is the current flowing through the 1 kilo ohm resistor?
1 ampere.
1 ampere.
Yes. So it's 1 square into the resistor is 1 kilowatt. So it's basically 1 kilowatt. So the power delivered by the resistor is minus 1 kilowatt. It means basically the resistor is absorbing 1 kilowatt power, right?
Yes, ma'am.
Yes, ma'am.
Okay. We'll move to the next question. So there is a 5 ampere current source connected in parallel with the 3 ampere current source. Then there is the 1 ohm. Then there is this 2 ohm resistor. Again there is a 3 ohm resistor. 4 ampere current source. And there is a 6 ampere current source. Now, my first question is find the power delivered by the 5 ampere current source. Yeah, try finding it. Take your time, then we will solve it together. How to solve it?
Ma'am, 75 watts.
No, it's not 75 watts.
Okay.
How did you get 75 watts?
Ma'am, we had to find due to 5 ampere source. That's why I remove all that sources. Only consider 5 ampere source.
Ma'am, is it
And
minus 5 watt?
No, it's not minus 5 watts. Oh, so you basically tried superposition principle, right?
yes, ma'am. So
But you
if we
shouldn't do
remove
that like that.
all that,
You shouldn't
ma'am,
remove
all
the
that.
sources.
Okay.
Hmm. What is the
So ma'am, we
formulas
can
of power that we know?
P is equals to
1 is I
IV.
square S.
V square by R.
But
R.
ma'am, what
Yes.
is meant by power delivered by 5 ampere source? What is meant?
Yes.
Like power delivered by 5 ampere source, like whole circuit, how much power it is delivering?
No, this component, how much power it is delivering to the rest of the circuit.
Yes.
Ma'am, maybe 0 watts.
No? You have to try finding it using calculation, right? See, I
Uh,
know power. See, there is no resistor here. So I will eliminate these two formula. I have only this formula. P is equal to VI. I know the current, which is 5 amperes. I just have to find the voltage across this current source, right?
yes, ma'am.
So basically, I'm going to find the voltage at this point, which will give, since this is a common ground, if I find V1, that will give me the voltage across this 5 ampere, right?
Yes.
So if I get V value, V into I will give me P. So finding this V value, you can use any method. You can either use KVL or KCL. You can mark 3 nodes. You can do nodal analysis and find these 3 voltages. That is one method. You can also apply KVL or superposition, any method. Just find V1. What is Vx? What is V1? Sorry, what is V1? Did anyone find V1?
Ma'am, I got 4.
What did you get?
4 lakh 4.
12? 2.
4. 4.
Your voice is little bit breaking. Can you
He
write it
got
in the
4,
chat
ma'am.
box?
4.
4. Oh, you got B1 as 4?
Yes, ma'am.
No, V1 is not 4.
Is it 2?
Yeah, it's 2 volts.
Yeah.
Yes, ma'am. I also got it too. Because Vx will be 0, so V1 will be 2.
Yes.
So, ma'am, it will be, I think so, minus 10 watt
Why is it
power
minus
delivery.
10 watt?
Ma'am, because it is traveling from negative to positive.
See, positive minus I. If it is like this, what is the power delivered by this? Is it a positive value or negative value?
Negative.
Why is it negative value? It's a power delivered, right?
So,
So wait, 1 second. If there is a resistor R and the current I is entering through it, this is the voltage across the resistor. Power absorbed by the resistor is equal to, is it, just tell me whether it is a positive value or a negative value.
ma'am, positive.
Yeah, the power absorbed by the resistor is a positive value,
Yes,
right?
ma'am. Yes, ma'am.
No doubt here. Again, there is a resistor R. I will not give you this sign.
Power delivered by the resistor is negative.
Yes, here
Yes,
power
ma'am, it is
delivered by
negative.
the same resistor is negative. That is also true.
Yes, ma'am.
What about this? What is the power absorbed here?
Ma'am, power
Positive.
absorbed will be,
Positive.
ma'am, negative.
Yes. Why is it negative? See the sign of the voltage? Okay. I will not say, change the
Oh,
sign.
okay.
Plus
Yes, it
minus
is
R.
positive.
What about now?
Power absorbed.
Hmm.
Ma'am, it will be negative.
Why?
It is
Because,
leaving from the positive terminal of the resistor.
yes, ma'am, it is entering
If
from
I
negative
just
and
complete the
leaving.
circuit, see the circuit carefully. See, only if the voltage is reversed, the current will be flowing in this direction. Now tell me what is the voltage across the resistor in this direction?
Minus V.
Yes, it's minus V, right?
Yeah.
Yes, ma'am.
Because basically, because of this current direction, it will be like this. Because
Yes, ma'am.
the same will be reflected here. Since I interchange the sign, the voltage will become a negative value. Now tell me what is the power absorbed by the resistor?
Positive.
Minus V twice. So
V.
Do you have any doubt here? Or is it confusing?
No, ma'am. Ma'am, but in the same circuit, if you ask what is power like delivered by that V.
Power delivered by V will be positive.
Okay, ma'am.
See, here there are two terms which determine the sign, right? One is the factor, that is whether the question is absorbed or delivered,
Yes, ma'am.
positive or negative. This can be positive or negative. If
Yes,
it is
ma'am.
the voltage source, there is this voltage source V and the current is coming out of it. What is this configuration? Is the power delivered or absorbed?
Delivered.
Delivered.
So my delivered will be positive, and if the question is absorbed, we will put it as minus, right?
Okay, ma'am, because actually it is delivering. So if question is asking
Exactly.
how much, then it will be positive.
Yes. How much delivered if they ask, it is a positive because it is actually delivering. In the question, if they give the same voltage source and the current is coming out of the voltage source, but in the question they have asked what is the power absorbed by the voltage source, then it is a negative value.
Okay, ma'am. Basically, we don't see like if it is coming from positive or negative. We see it is delivering or absorbing, and what question is asking.
Yes.
Okay, ma'am. Okay, ma'am.
Now, again to confuse, I will ask one question. There is a voltage source and the current is going inside the voltage source and coming out of the negative terminal. What is the power absorbed? Is it positive or negative?
Negative.
Negative.
Why?
Sorry, it will be positive
Positive
because it
power.
is actually absorbing.
Actually, the voltage source is
Voltage
absorbing the power.
absorb power. Yes.
Yes, ma'am. Yes, ma'am. Yes, ma'am. Now I got it.
Shall we summarize it once?
Yes.
Yes.
Yes, ma'am.
So there is a resistor R and there is a voltage V. The current is flowing in this direction. The same voltage will be across the resistor also, right?
Yes, ma'am.
Yes.
So if you take the voltage source, power delivered by the voltage sources
Positive.
plus VI. The power absorbed by the voltage sources
Negative.
minus VI. The same way, if I am considering the resistor, the power absorbed by the resistor is,
It will be positive and delivered will be negative.
yes. These two are with respect to a resistor in this diagram. These two are for this voltage source. Is it clear?
Yes, ma'am.
So basically, from the positive terminal, if the current is leaving, then it is delivering. And inside the positive terminal, if it is the current is entering, then it is absorbing, right?
Absorbing.
Shall I
Yes, ma'am.
generalize it like that?
Yes, ma'am.
So if there is a voltage source and okay, if there is another current source and then a resistor. This is a current source and this is a resistor. And the current is flowing in this direction. What is this voltage doing? Is it delivering or absorbing?
Ma'am, observing.
Absorbing.
Yes, it is absorbing. Clear, right? Shall we move to our question? Yeah.
Yes, ma'am.
So what about here?
Yeah.
Yeah, one second, give me a minute. In this configuration, tell me
What is the
the
delivering
power
so
delivered
Delivering. So it will be positive.
positive. So if I just have it like there is a current source and the voltage is like this, what about this one? What is the P delivered? Is it a positive or negative value?
Positive.
Yes. So now tell me in my question, what is the power delivered by the 5 ampere current source? Is it a positive?
How did we take it like the sign across that 5 ampere as like above the positive only?
Here, if you calculate V1, you will get as 2 volts. And here you will get 0.
Okay,
Right?
got it.
So the voltage is like in this direction. You can assume this in any direction. If you just assume it in this direction, you will get a negative value. value of the voltage. So that my final answer will be the same. Yeah. Now tell me how to find this V1, Vx, V2. We can apply KCL, right? So at node V1, the current entering is 5 ampere, the current leaving is 3 ampere, and there is one resistor also. So 5 is equal to 3 plus V1 minus Vx divided by 1, right? This is my one equation. 2 is equal to V1 minus Vx divided by 1. Then at Vx, what is the equation at Vx? So to find calculation at Vx, I'll assume all the current are flowing. Vx
Ma'am,
minus
V1
V1 divided
plus
by Vx minus V2
by 3.
by 3. Yes.
Yes, V2 divided by 3 plus Vx by 2 will be equal to 0. At
Yes.
V2, this is leaving, this is entering, this I will assume it as leaving. So V2 minus Vx divided by 3 plus 6 equal to 4. So V2 minus Vx divided by 3 is equal to minus 2. So what is the value of this?
0.
No, what is Vx minus V1 by 1? It's minus 2, right? From this equation. And this value is plus 2 plus Vx by 2 equal to 0. So Vx is equal to 0. So since this is a 0 volts, I can apply Vx is equal to 0 volts in this first equation. So 2 is equal to V1 by 1, which is equal to V1 is equal to 2 volts. So my voltage is 2 volts. So the power delivered by the 5 ampere current source is 10 watts, right? Did you guys get the same answer? Did anyone have any doubt in this?
No, no, clear.
So in the same question, find the power absorbed by all the resistors. We have already found V1 is equal to 2 volts, Vx is equal to 0 volts. You can find V2, then find the power absorbed by all the resistors. That is basically the sum of power absorbed by the 1 ohm resistor plus power absorbed by the 2 ohm resistor plus the power absorbed by the 3 ohm resistor. Tell me the value. What is the power across the 2 ohm resistor?
So across 1 ohm resistor is 2 watts, and across 2 ohm resistor is
0.
0 watt. 0.
Why is the power across the 1 ohm resistor is 2 watts?
Ma'am, because 5 ampere currents coming upwards and 3 ampere currents going downwards. So remaining currents means 2 ampere current is going through 1 ohm resistor.
Then
We
it is
have
I
to-
square R, no?
What?
Power is I square R, right? So 2 square into 1.
Yes. P is equals to IV also, no ma'am. We know the 2 ampere across 1 ohm.
Yes.
And V is equals to 2 volts. Yeah,
Yes.
4
Yeah, 4 watt.
watts.
Yes.
Yes.
So the power across the 1 ohm is
4 watts.
4 watts.
Ma'am, I think total power absorbed by all, like with 2 ohm will be 0,
Is it 8 watts?
Yes.
and 3 will be 6. So total will be 10.
Why is it 6? What is
4 watt,
V2?
right?
V2 will be 6.
Minus
Is
6.
it 6?
V2
Plus
is
6 or
8.
minus 6?
Minus 6.
Yeah, V2 will be minus 6. But just we don't need to find V2 for finding the power, right? You can see the I apply KC at this point. 4 ampere is entering, 6 ampere is leaving, so this will be 2 ampere. You can use I square R. I is 2 square into 3. Right?
Yes.
How did you get? So this will be
12.
12 watts.
Yes.
Do anyone have any doubt in this question? Or are you all getting the same answer?
Yes.
Yes. Yes.
Okay.
How like can we use that V square by R value
V square
for
is,
P3?
yeah. You can use V square by R also. 6 square divided by 3.
Okay, got it.
Shall we move to the next question?
Yes, ma'am.
So this is my fourth question. So there is an amplifier A. There is a V in and there is a output voltage coming out of it. And this is my VDD. This is my VSS. Let it be some 8 volts and let it be minus 8 volts. My V in is 25 millivolts. And my output is, you have to find the output given the amplification factor is 7. Find V out.
175 millivolts.
175 millivolts. What's the formula for V out?
A into Vn.
So A is 7 into 25 millivolts. What type of amplifier is it?
Non-inverting.
No.
Yes.
Ma'am, how can we find that inverting or non-inverting?
If this gain A is positive, then it is a non-inverting amplifier. If the gain is a negative value, then it is an inverting amplifier. So whatever positive values you give in, you will get a negative value out. And if you give a negative value in, you will get a positive value out. So your negative gain basically inverts the V in the opposite, positive or negative, right?
Okay.
So we'll go to the next question. So a step input of 5 volt is given to a RC circuit as shown below. Voltage across the capacitor at time t is equal to 0 is equal to 2.5 volt. Find Vc of t. So there is a circuit also. 1 k ohm, 1 microfarad. So this is the voltage across the capacitor, and also the initial condition they are given. The voltage across the capacitor at time t c is equal to 0 is 2.5 volts. You have to find Vc of t. And what does step input mean?
Input voltage?
Input is positive like after 0.
Yes. So at
Ma'am, can
0,
you again tell its formula because that day I was not able to.
yeah, 1 second is. What formula? Formula for Vc of t?
Yes, ma'am.
Yeah, okay.
Ma'am, basically, can you once solve this question and then other we can solve? Yeah, you can.
Ma'am, what is the value of resistor and capacitor?
Okay, yeah. 1 second. The resistor is 1 kilo ohm and the capacitor is 1 micro ohm. Those who already know the formula, you can try
Okay, ma'am.
solving it. For those who don't know, I'll just give a summary of that. Okay.
Okay.
Yes, ma'am. Yes.
So yeah. So this comes under this topic RC step response. Okay. So what is a step input is nothing but it is a signal that looks like this. That is, for the negative value of time, there is zero input. Once that for the positive values of t, you will have some certain
One.
value. If it is yes,
Yes. Always one,
if it
ma'am.
is,
Step in.
but see in this question, they are given step input of 5 volts. That means instead of 1, you have to
Okay.
replace it with 5. Yeah.
5. Okay.
If they give only step input, then it means 1.
Okay.
Yeah, for example,
So
if
this
they
is
give
the
unit step input, then it will be 1.
yes. So this is the step input. Okay. This step input we are going to give to a RC network. This is R and C. And we are going to see the response. That we call it as RC step response. Okay. We are basically going to find here VC of t.
Is it
When
1
this step
plus 1.5 to the power minus t?
yes. Can you please repeat?
1 plus 1.5 to the power minus t.
Is it the full formula?
Ma'am, we should use the discharging formula, right? Because we already have an initial value, or
Yes. See, wait. So here we would have for 1 second. So those who in the derivation, actually we would have in some point. See here, we found the equation. Here we applied the initial condition. Here we have taken it Vc of 0 is equal to 0, and we found Vc of t at time t is equal to 0. We applied, right? But here in this question, they are given Vc of 0 is equal to 2.5 volt. So you take this equation, apply this condition at time t is equal to 0, apply Vc of t is equal to 2.5, find the value of C.
It's 1.5.
Is it 1.5? Please check the calculation again. Okay. So yeah, that problem I will solve it after 5 minutes. You can write the answer in the chat box, okay? So yeah, so this is a unit step input. Once I give it to a RC circuit, whatever output I am getting across VC of t, that I am calling it as RC step response. So basically, I have this U of t. The voltage across the resistor is VR of t. I am going to find VC of t. I am going to derive an equation for VC of t. The one who asked this doubt, do you want me to explain you how the derivation is?
No, ma'am. No, ma'am. No, ma'am. Not the whole derivation.
Okay. So I'll just go to the final answer, okay?
Yes, ma'am. Yes, yes.
So we would have derived this equation. Vc of t is equal to 1 plus C e power minus t by RC.
This is the formula, ma'am. We had to use to solve like circuit like that.
Yes.
Okay, ma'am. And this is the
Okay.
basically main formula to find VC of t.
Yes.
RC circuit across.
So
Ma'am,
when
rest
does this
all the derivation is not very important.
you can't say like that, because without understanding the derivation, you don't have to memorize the derivation. Just understand
Yes,
how
yes.
the subsequent steps are coming from the previous steps. That is enough.
Okay.
So yeah. So what is the condition? When will you apply this formula?
To find the voltage
And
across.
V is a
When
unit
the
step.
input is a yes step input.
Unit step.
Yes, it's a unit step input.
Okay, ma'am. Only then it is valid.
We had
this
to
one.
change, remove that one, and we had to put that value of voltage.
Ma'am,
If it
VM
is
is
just a
basically the step input. How
yes,
much
5.
value?
That 5 volts which is up. If the input is a step input, if it is a unit step input, you just take Vm is equal to 1.
Okay.
If the input is a step input of some value, you will consider that value also Vm. Now, if the initial condition Vc of 0 is equal to 0, my equation will be okay.
VM into 1 plus C into minus T by C.
So Vc of 0 is equal to 0. What does it say? At time t is equal to 0, my Vc of t is equal to 0.
Yes, ma'am.
So I will apply this equation here.
Okay, ma'am.
I will apply this equation in the unit step inputs formula. So that I'll take Vm is equal to 1. Okay. So Vc of 0 is equal to 1 plus C e power. Instead of t, I will replace it as 0. And I have seen here Vc at 0 is 0. So 0 is equal to 1 plus
So,
C
ma'am,
e
by
power
it, we will
0.
calculate what is the value of C.
Yes. So this
C is
initial
minus
condition
1.
is used to calculate C, right? So you'll get CS. What is the C value you'll get? Minus 1.
Okay, ma'am. But if already we are given with value of C, so there is no need to do this.
Yes. This is for unit step input. Given Vc of 0 is equal to 0. Only then you can use this formula.
Ma'am, here E is energy or what?
Exponential.
Exponential. Ma'am, is the C there a constant? C equal to minus 1 is a
Yes,
constant, right?
Yes. Because since you are integrating here, by integration you always add a constant, no? That
Yes,
C
ma'am.
is only this one. So for now, what is the most important formula is this one.
Okay,
I'll
ma'am.
just write it here. Vc of t is equal to Vm 1 plus C e power minus t by Rc.
Actually, ma'am, this question slide of that day, which you on which you taught this, I was not able to find in that link.
Ma'am, is C 4 by 5. Minus 4 by 5.
No. C is not 4 by 5. Yeah, I have uploaded it. Can you please check it again? Because see, there are many subtopics under supplementary content. Under you can go to live session slides.
Okay, ma'am. I will check.
Yeah. Because I have uploaded till last week. All the sessions that I have taken.
Sorry, minus 1 by 2.
Yes, it's minus 1 by 2.
Okay.
C is equal to minus 1 by 2.
But of capacitance is given, na 1 microfarad.
Okay. 1 second.
Yeah. Why are we taking that minus 1?
No, this C is constant. This C is not capacitor.
Constant.
Yes. This is constant. This is small c.
Okay,
This
okay,
is
okay.
that is a large c.
Ma'am, can you do how we are getting C is equal to minus 1 by 2?
Yeah. So my Vc of t equation I will take. So this is the formula, right? 1 plus C e power minus t by Rc. And I have given that initial condition. So at time t is equal to 0, my value of, so I'm going to calculate for time t is equal to 0. My at time t is equal to 0, Vc of t is 2.5 volt, Vm is 5 volt. Since C, this value is Vm, Vmax. 1 plus C e power t is 0, right? So 0. E power minus 0 is equal to e power 0 is equal to 1. So 2.5 divided by 5 is equal to 1 plus C into 1. So C is equal to 1 minus
1 by 2.
okay. Is it 1 minus 1?
1 by 2 minus 1.
1 by 2 minus 1.
Yes. So it's minus 0.5.
Why would
So
it be
VC
1
of t
minus
should
2?
be like 5 into 1 minus 1 by 2 e power minus t. Right?
Yeah, 5 into 1 minus 0.5 e power minus t by, what is the value of R and C? It's 1k into 1 micro, right? So
1
VC of
millisecond, ma'am.
t, yes.
Okay, ma'am, I found that notes.
Okay. 1 milli into t. Now,
Ma'am, time is equals to R
find
and C, R into C.
yes, tau, that is time constant now. So we'll go to the next part of the same question. See, we have found VC of t. Find the value of VC of t. No, find the value of t given VC of t is equal to 3 volts. Find the
Ma'am,
value of t.
we had 1 milli in the denominator. Sorry, ma'am. Okay.
Yeah, right. You have 1 milli in the denominator. Sorry. T divided by 1 milli. Yes.
And ma'am, why minus sign is involved? Minus
Minus t by 1 milli.
Yeah, minus t.
Ma'am, it should be log of 4 by 5 into 1 m 1 milli. Sorry, 1 millisecond.
Yes. Calculate no ln 4 by 5.
ma'am, we have to simplify log also.
Is it log or ln? ln or log?
ln.
ln. Yes. Simplify, use calculator.
Okay, ma'am.
I mean the calculator in the portal. You can use that.
So 0.2 millisecond.
Yes. Right. So basically, VC of t we are given 3 is equal to 5. 1 minus 0.5 e power minus t by 1 milli. 3 by 5 is equal to 1 minus 0.5 e power minus t by 1 milli, which is nothing but 0.5 e power minus t by 1 milli. I'll take to this side. So 1 minus 3 by 5 is nothing but 5 minus 3, it's 2 by 5. Right? So e power minus t by 1m is equal to 2 by 5 into 1 by 0.5. 1 by 0.5 is nothing but
2.
1 by 1 by 2. So 4 by 5. e power minus t by 1m is equal to 4 by 5, taking ln on both sides. Ln and e will get cancelled. So minus t by 1m is equal to ln 4 by 5 minus t equal to 1 milli ln of 4 by 5. So you will get ln 4 by 5 in some negative values, right?
Ma'am, I think it should be plus 1, sorry, minus 1 plus 3 by 5.
Minus 1. How?
Okay, okay, fine, fine. No problem, yeah. Because ln is negative, so okay.
So ln will be negative. Then negative will get cancelled. So t is equal to 0.223 millisecond. Yeah. Do anyone have any doubt in the questions which we saw today?
No, ma'am. Ma'am, can you give one more question like this so that practice can be better?
Shall we take one question from the practice assignment?
Yes, ma'am.
Okay.
So ma'am, like unit step versus step input, like unit step input versus step input. So
You want to know the difference?
yeah, like unit step input, we are just taking like u of t, and step input we are taking vm into like u of t.
So step input is just, it is stepping at 0. So we call it a step input. So this one is done. Unit is nothing but 1. If the step input has a magnitude of 1, then we call it as a unit step input. If it is
Okay, so
only a step
VM is,
input of some value, yeah, it will be VM.
Okay, got it.
Yeah, consider this question. This is the practice
Ma'am,
assignment.
time constraint means C now.
Huh?
Like in third, it is asking time constraint. So time constraint is C
No,
now.
it's time constant tau.
Yes,
It's
ma'am.
nothing but R into C.
Okay, okay.
Because C, e power minus t by RC, right? What is the unit
Yes,
of this
ma'am.
RC? It's actually time constant. RC time
Yes,
unit is seconds.
Okay, ma'am. Ma'am, R will be the resistance and C is the like constant which we will calculate.
It's, no, C
No,
is a
C is
capacitor
capacitance.
Oh, here it is capacitance. Okay.
and resistance.
Okay.
And tau is time.
Yes.
Tau is time
So
constant.
So its unit is millisecond. Oh, its
Now,
unit is
what
in
is the
second.
difference between time constant and time? Like,
It's just R into C value. We are just giving a name to that time constant.
So ma'am, it will be I think so 25 millisecond, no? Because resistance will be 5 kilo ohm. So
Yeah. Wait, one second.
Yes,
Let me
yes.
check the answer. Yeah, it's 25 millisecond.
25.
So R into C. R is nothing but the equivalent of this
5 kilo.
5 kilo ohm. 5k into 5 microsecond, which is nothing but 25 millisecond. Now they are given step input of 5 volt. That means this is given as an input, and they are given the initial condition as 0 volts. and we have to find the time taken for the voltage to reach 2 volts. Same, you have to find the time. Try finding and tell me the answer. Let's see whether it is matching with the answer in the portal.
Ma'am, that is the symbol for step input, V of t, that logo.
This is the symbol for any AC signal.
Okay, ma'am.
DC signal will represent it with the plus or minus. This is a symbol for an AC signal. AC
Ma'am,
signal
we
is
got 25 milliseconds. It is not a time.
this one. Yeah, it's a time constant, no? Something that has a unit second is time only.
Okay. And ma'am, one
right,
thing
sir.
I want to ask from that previous formula, we see that what is that minus e do here, ma'am? Exponent.
How that exponential came here.
Yeah, and what is the use of it? What is it?
Okay. So we solved something and we are getting it right. Okay. We will understand it. So this is my step input, right?
Yes.
This is my u of t. And
Ma'am,
whatever
I
the
think
formula
it
I have
will
found.
be 5 milliseconds.
U of t, U of t, ma'am? Yes.
U of t is the input. And this is
Yes.
the voltage across the capacitor, right?
U of t. U of t.
So this is for understanding I'm drawing, okay?
Yes.
So what does that say? This exponential term.
Yes, ma'am.
At time t is equal to 0, what is Vc of t?
Zero.
This, yes. This is 0. This term will be 0. So my Vc of t will be equal to Vm.
Ma'am, when you talk like Vc of t, I don't understand what do you want to say that.
See, Vc of t is nothing but the voltage drop across the capacitor.
Okay. Okay.
So that's what I'm saying. See, what we are doing, we are going to find RC step response, right?
Yes.
There is a RC circuit with resistor and a capacitor. We are giving a step input. So there is a RC circuit, we are giving a step input and finding the response, how the output will be. We are just analyzing how is the output Vc of t when u of t is applied across the RC circuit, right?
Yes. Given a step input.
So we basically derived how the Vc of t changes over time. For that, we have got this equation,
Okay.
right? Numerically, you are understanding how we are getting this one. But you want to understand what this E of t is doing here, right?
Not V of t, ma'am. I want to understand
This
what
e
is the
power-
minus e doing here.
Yeah, see, wait. So what it is saying is,
It came from the derivation like minus e.
he wants to know the derivation or
What is minus e? Like we know that C is equals to capacitance, R is equals to resistance, mu.
E is the
So E is
exponential
a
term.
exponential
What is
function.
denoted?
Exponential function.
Because I had problem in function, that's why I don't know like exponential what does.
See, after this, in this derivation, we can't directly find Vc of t here. So to make my equation easier, I'm just multiplying with e power p dt everywhere. So I'm just introducing an exponential term.
Like we take a variables x, y like that.
That is not a variable. Exponential term is a wide known. It is like, this is a exponential term.
Okay, it is going downwards.
Yes.
We suppose that. Okay.
Like it is not a linear function. but it is
Yeah.
something moving down or moving up in an exponential fashion.
Yeah, but it is constant like that.
Have you heard of this term e power x? Have you
E
come
power-
across this equation?
No, man.
So, okay. So, in mathematics, there are different functions, right? Y is equal to x. How will you draw y is equal to x?
Ma'am, are you
Will we-
solving the question?
No, no. It's just to understand what is that e power
Oh.
x.
Ma'am, is the answer
What is y?
12.75?
Yes.
Okay.
when we take a one point at same distance from the x and y.
So this is a function, right? Y is equal to x. Because if x is 1, y is also will be 1. X is 2, y will also be 2.
Yes.
So what is y is equal to x square? If x is
Square.
1, y will be 1. If x is 2, y will be 4. So it is also a function. Similarly, y is equal to e power x is also a function.
Okay. In the power of something.
Yes.
Okay.
So and it will be increasing like this.
Okay.
So e power x is a function. Mathematical
Okay.
function.
Okay.
So actually, what I was trying to say is, e of t is the input which we are giving.
Yes.
So at time t is equal to 0, Vc of t will be 1 minus 0. So it is Vm. And as time gradually goes, the voltage drop across the capacitor will become 0. It will be exponentially decreasing, right?
Yes.
So that's what that exponential term actually means.
But
So
ma'am,
that's what
question
the
it is given
Time
like
it
when
happens some changes like
yeah, come again one by one.
ma'am, I was saying in question it is given like when t equal to 0, so Vc of t equal to 0. That figure.
That figure Vc of 0 is equal to 0. Yes, at time
Yes,
t is
ma'am.
equal to 0, Vc of t is equal to 0. That's what
Yes, ma'am.
by this. So initially, the capacitor has no energy within it, no voltage stored in it, potential in it.
Yes, ma'am. So ma'am, this condition we will use not to calculate C.
C
Yes.
is not necessary in this. We need not calculate C here. We'll just find the time constant and just substitute the. Just go with the second question. Like substitute 2 volt is equal to 5 into 1
Can
minus
either
C power.
use this formula and you can find C applying the condition. Otherwise, you can directly use that 0 condition which we already found, right?
Yes, ma'am. This is one
Yes.
step less.
And so answer will be, I think so, 5 millisecond.
12.75.
Yes, the answer is around 12 to 30.
okay.
It was like ln 3 by 5 into 25 milliseconds.
Yes, ma'am. But ma'am, ln 3 by 5 will be, I think so, 0.22.
No, minus 0.5.
Minus, yeah.
Yeah, it's around like 12.77 ampere.
Yes. 12.77 millisecond is right. So basically, you'll get an answer in between 12.13 to 13.41. Right?
Yes, ma'am.
Shall we move to the next question? Or,
But
okay.
I think so. ln 3 by 5. Ma'am, How L3 by 5?
do 3 by 5, do open bracket 3 by 5, then close the bracket, then press on ln. It will give you ln 3 by 5. First 3 by 5, then press ln.
Okay.
And 3 by 5, enclose it in a bracket. Ma'am, how are we supposed to find whether we should use the charging or discharging formula from the question?
This is a general formula, right? Here, if you put t is equal to 0, Vc of t is equal to 0, you will get this formula. So you can start here or you can start from here. What
No,
is the
ma'am,
discharging formula you are talking about?
that is that Vm is equal to just a minute, e power minus t. It's directly like Vc of t is equal to V initial into e power minus t by time
Like this,
constant.
right?
Yes, ma'am, that one. When to use it?
This one? Okay. I think you already watched the next lecture, huh?
Yes, ma'am.
Okay. Yeah, give me a minute.
It is in midway.
Like what wordings will be there in the question that will make us realize we should use the discharging instead of charging? That is my doubt, ma'am. Like what are the words, like what words will they use in the question?
Okay. You want to know why we will use e power minus t by RCVM, right?
Yes, ma'am. In what kind of like what will the question mention so that we will have to use this formula instead of the other one?
We found Vc of t, no? That is nothing but Vm 1 minus e minus t by RC.
RC.
And this one is Vm step input. And this one is V in of t. How to find Vr of t? It will be nothing but V in of t minus Vc of t, right?
Yes, ma'am.
So my V in of t, let me take it as Vm minus Vm 1 minus e power minus t by RC. So Vm 1 minus 1 plus e power minus t by RC. Are you getting the formula which you are mentioning?
Okay,
So
ma'am.
it's basically the voltage drop across the resistor.
Okay, ma'am. Okay.
So yeah, here only I wanted to show you something. Yeah. My V in of t is Vm. My Vc of t is Vm 1 minus e power minus t by RC.
RC.
My VR
And this
of t
VC of t is
equal to,
basically when VC of 0 is 0, no?
yes. Here, yes, the condition. P of 0 minus is equal to 0. This is true only for that. E power minus t by RC. Now you'll just plot. This is time. This is my V in of t, right? Now next I will plot my Vc of t. Vc at 0 is 0. Vc at infinity, what is that? Apply infinity in time t and tell me what is Vc of infinity. That is nothing but Vm 1 minus e power minus infinity. So yes, it's Vm. 1 minus 1 by e power infinity. E power infinity is infinity. 1 by infinity is 0. So it's Vm 1 minus 0. It's Vm. So my capacitor, as time goes on, it starts from 0 and it reaches Vm. So this is my Vc of t. Now tell me what is Vr at 0 and Vr at infinity?
We are at 0 is Vm.
And Vr at infinity is 0.
0.
Yes, ma'am. It will take the
So this will
opposite
be-
curve.
Yes. This is so basically at any point, Vn of t will be equal to Vr of t plus Vc of t, right?
Yes, ma'am.
And the exponential term says that is exponentially increasing or exponentially decreasing.
Yes, ma'am. Ma'am, but they called it as discharging. So is VRT equal to the same as discharging of VCT or something like that? They used the-
Discharging is related. Okay. I am not exactly able to understand what you are saying, but
No, ma'am, it is fine. I am able to
Okay.
get it.
so when
Can you explain the graph? Like, so what is happening with VR and what is happening with VC?
Yeah, 1 second. If they say Vc of 0 is equal to 0 means that the capacitor is initially discharged. So what do we say when we say, what do we mean when we say the capacitor is charged? If I connect a capacitor across a voltage source, okay?
All the
Now-
charges have been, it's
Yes.
the,
Then suddenly I will disconnect it. Still the potential will be remaining there, right?
yes, ma'am.
Yes.
Okay. So this is a charged capacitor. The capacitor, it actually has some charge in it, stored in it. Now if I connect it to some resistor, then there will be some current flow till this charge depletes. So these type of questions now you will be seeing in week 11 and 12. So initially discharged means that capacitor, its initial Vc of 0 value is 0. It has no charge in it. Like it is not carrying any charge currently at time t is equal to 0. That's why it is called initially discharged. Is this term clear?
Yes, ma'am. There is no charge at t is equals to 0.
Yes, it is discharged. All the there is no like potential stored in it initially.
Yes. 0 volt.
Okay. Someone was asking me to explain the graph. No, can you please repeat what you want again?
I just want to know what exactly happening with the VC and VR, like how, need you to understand.
This is at time t is equal to 0 and at time t is equal to infinity.
So can we get question on this graph also?
No, this is just for your understanding. You can, they might ask, but understand it, no?
Okay, ma'am.
Okay. So this is my Vin of t. This is my Vr of t. This is my Vc of t. So, initially, voltage drop across the capacitor is 0, right?
Yes, ma'am.
Yes.
And the voltage drop across the resistor is maximum. It's Vm.
Because the current is flowing through it, the first, like, so yeah.
But as time goes by, at time t is equal to infinity, the voltage drop across the capacitor becomes Vm.
What is VM, ma'am? Voltage across?
Vm is nothing but Vin. Vmax. Vn is a stepping with
Maximum.
maximum 5.
Okay.
Like, it has got a full charge, like, from VM. So it is VM.
Okay.
it is this Vn is nothing but a constant supply, right? It is not changing signal. It is a constant supply. So initially, what happens is for DC at time t is equal to 0, initially the capacitor will act as a short circuit. Okay.
Yes.
And at time t is equal to infinity, the capacitor will act as an open circuit, right?
Yes, sir.
Yes.
At time t is equal to 0, when capacitor is a short circuit, what will be the voltage across the resistor? It will be
VR
exactly
which is equal to Vn. Vm.
Yes.
Yes. At time t is equal to infinity, my capacitor will become open circuit. So what will be the current flowing in the loop? It will be 0.
0.
What will be the voltage drop across the resistor?
0.
0. Like that.
0. So all my potential will be across this BC.
When time is equals to 0 or time is equals to infinite?
At time t is equal to 0, capacitor will act as a short circuit. So the voltage drop
Okay.
across the capacitor will be 0. At time t is equal to infinity, capacitor will act as an open circuit. Voltage across the resistor will be 0. Voltage across the capacitor will be Vm.
Yes. Ma'am, when it is short circuit, then the voltage across the resistor is the voltage given.
So these are the concepts you will be actually learning in week 11, week 10, week 12.
Okay. So this week content is, ma'am, important for the upcoming weeks like
Yes.
8, 9, 10.
Knowing capacitor is very important.
Okay. But RC circuit
How
like
it acts at,
question like RC circuit that like graph and that we are finding that.
see, the next week, week 7, you will be seeing high pass filter, low pass filter and band pass filter. And all these filters are made of this RC combination only.
Yes.
So knowing this one is very important for your upcoming weeks. So be clear with the equations, and knowing
Yeah.
this capacitor is very important for your week 9 to week 12.
Okay. RC
Ma'am?
step response, ma'am. This topic name. So it will be easy for me to.
Yes, understand further topics.
Ma'am,
Yes, sir.
if the VR is if the voltage across the resistor is 0 at infinity, won't it be same as the resistor itself is an open circuit? Why isn't not the same?
Now, can you please repeat?
At infinity, voltage across the resistor is 0, then won't that
Yes.
form an open circuit of its own?
Yeah. See, basically the only voltage will be okay. What you're asking, see, there is a resistor there, no current is flowing, no drop across the voltage also.
Oh, so there will be no current flowing, but because the capacitor is fully charged, it will be storing the same voltage as the input voltage.
Yes.
Okay.
So as you said, like in the week 11, if you remove the voltage source, then the resistor will gets like the current.
Current from the capacitor.
Yes.
So at time t is equals to 0, then voltage across that capacitor is same. What the voltage across the VM?
Okay, wait. Let me draw it clearly.
Ma'am, just to be clear, this V input is like a DC. Sorry, it's like constant as we took, right?
VC is constant.
No, V. Sorry, V.
So
Like it's
for
a
here,
DC.
I think,
If it's a step value, it's a constant. It can also be a sine input.
yeah. See, first, let me also bring to your notice about the difference between this DC step input and other type of signal. What is the difference between the DC and the step input?
DC is just any
constant value.
Constant.
For positive and negative, but step input, that stepping at 0 is important. Okay, that's the difference between these both.
Okay, we can also get an AC V in as well, right?
AC V in. Yeah, so actually, see, in week 7, In this week 6, we saw about the unit step response, right?
Yes, ma'am.
So basically, we found out BC of t, and we also found BR of t. Then step input is given. In the next week, you will see the same circuit, but my input will be a sine wave, a sine omega t.
Now
And
we
we
are
will be
dealing
deriving
with
the
a square
equation.
wave.
Now we are telling
Okay,
with,
okay, got it, ma'am.
yeah. Okay, actually, I thought of taking week 7 summary also today. What do you think? Shall we go with week 7 summary?
Ma'am did not watch all the videos.
Okay, have you started watching?
No, ma'am.
Today I was
Uh,
the first video.
Today I was completing week six graded assignment.
Okay.
Still in week 6, ma'am.
Can we give a topic based like on that?
Like on that?
Because I think so in half an hour we will not
Yeah.
be able to complete it.
Yeah, that's what I'm also thinking. Okay, then week 7 summary we'll see in the next class.
Okay.
Then I will see
Next
if
class
I can.
is 6th November, right?
It will be on Friday, yes. Because Wednesday's class has been postponed to Saturday, 6 to 7.
Yes. Ma'am, Friday means in morning 9 to 10. No?
Yes, 9 to 10.
Okay. So that class sir will not take. You will take.
Sir will be taking.
Okay, okay.
I think I'll be taking the next Saturday's class. Not this Saturday's class, the next Saturday's class.
Okay.
So, ma'am, if there are no problems, we can just do the summary.
Yeah, wait, let me see whether there are another practice assignment. If not, I'll just give a summary and then we will end the session. Okay?
Yes, ma'am.
Yes, ma'am.
Okay, there is a problem in practice assignment itself. It is related to, okay, we're also given the answer. Yeah, no problem. So, for the amplifier shown below, Vin they are given us 10 millivolts. Amplification they are given us minus 10. And here to find V out. What is V out? Since I have taken inverting I haven't solved any problem related to inverting amplifier.
Ma'am, 100 minus 100 millivolt.
Yeah, it will be minus 100 millivolt. And in the question they have asked in volts, right? So it will be
Minus 0.1 volts.
yes. Okay. So basically in this week 6, we saw about amplifiers. 2 types non-inverting. Another one is inverting. Then we saw power conventions. You might be asked to find the power delivered or absorbed by the voltage source or a current source or the resistor.
Yes.
Then we also saw about the RC step response, right?
Yes.
Just tell me the if it is a step input of Vm given to RC network. What is the general equation for Vc of t?
Vm into 1 plus C e power minus t power minus.
This C is a constant. This R is a resistor and C is a capacitor. And RC is nothing but the time constant. Right? Yeah. If any of you have any doubt, you can ask. If you don't have any doubt, you can leave the session.
Okay, so week 7 summary we will cover in next class.
Yes.
Ma'am,
when
my
you say, when you tell about that VC of T means you are talking about voltage across the capacitor.
Voltage drop across the capacitor. Yes.
Okay.
ma'am, why should we use this 1 plus CE formula every time instead of directly using that another derived formula?
That depends on the condition, right? If they say initial condition is equal to 0,
Use the
you
other
can
one.
use
Okay.
VC of T. Yes. Vm 1 minus e power minus T by RC. If
If
it
they
is
have
not
given
given,
like
just
okay, ma'am. We have to
you
find
got to
C and
use.
then okay,
Yes,
ma'am.
exactly.
Ma'am, but to find the value to find the value at a specific T or to find the value of T at a specific voltage, they have to give like a second question, right? What will be the voltage in the second condition? They can't like directly use the initial condition to find a final
No, no,
time or a final voltage, right?
no, you can't use.
Okay, ma'am.
Yeah. Any more doubts? The practice
No, ma'am.
assignment or okay.
Thank you, ma'am.
Yeah, thank you.
Thank you, ma'am. Thank you, ma'am.
Yeah, thank you.